Muddy on the road, muddy on the beach. Feel it in the air, the sun's out of reach. Empty lake, empty streets, the sun goes down low. I'm driving by your house, though I know you're not home, and I can see you. Your brown skin shining in the sun. You got your hair combed back and your sunglasses on, baby. And I can tell you my love for you will still be strong after the boys of summer are gone. Hello everybody, welcome to this edition of video notes for Mr. Flugum's general chemistry class. That's right, this is for Gen Chem. And for all of you out there with your notebooks ready, this is going to go on page number 18 in your chemistry notebook. Well, thanks for tuning in, you guys. We're going to be talking about atoms today. Let's go ahead and get started. Alright, so as we talk about atoms, we need to figure this out, right? And we talked about this a little bit on the last video notes that we did. What's the definition of an atom? Well, you can see the definition right there. Okay. And then, what does an atom look like? Well, we have this idea of an atom. It's called a model because we can't actually see an atom, right? The wavelength of light is too short and we don't have microscopes that can do all that kind of stuff, right? So we infer what an atom looks like based on evidence and experiments that we've done. And through those inferences, we've developed a model. Now our current model is called this, the electron cloud model. Okay? Now in the electron cloud model, there's two pieces. There's a nucleus, right? And there's an electron cloud. What we're going to do is talk about those two pieces in detail over the next couple of slides. Okay, so the nucleus. Nucleus is basically in the center of the atom, you guys. Okay, and it contains the most of the mass of the atom. In fact, you can really say all of the mass of the atom. We're talking about 99.9999999. Keep on going with that 9%. Okay, now the atoms are really small, right? So we have to have our own special measurement unit. So what we have are called AMUs, which are atomic mass units. These are units for measuring the mass of atoms. Okay, and they're special. They're their own unit. Okay, and we'll talk a little bit about that more here in a second. Now, as we look closely at this nucleus, there's two particles that you find in the nucleus: protons and neutrons. Okay, so protons have a positive charge. And they have a mass of 1 AMU, right? 1 atomic mass unit. So, as scientists have studied atoms, they've kind of said this. They said, hey, let's look at those protons. They have a mass of 1 AMU, and they're positively charged. The other particle is neutrons, right? So neutrons, like their name says, are neutral. They have no charge to them. Okay? And they also have a mass of 1 AMU. So, there's most of your mass, right, is in the nucleus. And that nucleus is really, really small. As we start talking more about atoms and experiments that we've done with them, we will talk about how small that nucleus really is. So you might be saying, what about that other part? And we call this the electron cloud model, Mr. Flugum, and that is correct. Basically, the electron cloud is the area around the nucleus, right? So it's the area around the nucleus, okay, and this is where the electrons are found, all right? So the electrons are found there. A couple things about electrons. They have a negative charge. And then here's the other weird thing about them. Although they have a negative charge and they do have mass, their mass is so small that it doesn't really matter. Their mass is 1/10,000th of an AMU. Okay, so their mass is so small they don't really matter. Now when we talk about these electrons, they kind of buzz around in that nucleus. Don't think of them as orbiting like planets around the nucleus. Okay, they are arranged though, however, in energy levels. So basically, the larger the energy level, farther is from the nucleus. Okay, so we will talk about that more. Okay, but remember this: electrons not orbiting like planets, and they hang out in the electron cloud. All right, let's continue on here. All right, you guys. So elements. Remember, this periodic table here contains all the elements that we know to exist. Okay, some of them are man-made and some are naturally occurring. Now, what determines what element an atom is? It's this. It's the protons. Okay, protons determine the element, you guys. Okay, and so if you change the number of protons, you change the element. All right, we can change neutrons and we can change electrons, but if you change protons, that changes the element. That's one lesson I kind of want to get across to you. Protons determine the element. All right, folks, last thing I want to do with you here is talk about periodic table basics. So when you look at a square on the periodic table, what is the information? Well, first of all, you have the name, okay? And things can be organized different on different periodic tables, but the information will always be the same. There's the name. You also have the symbol for the element. That is 1 or 2 letters, okay? In this case, Na is for sodium. It's based on a Latin name or Latin term for sodium. Other elements have a much more conventional symbol for them. Okay. You also have this. You have the atomic number. So the atomic number in this case is 11. It's always the whole number that is displayed predominantly in the square. Okay, that's the atomic number. And then you see there's another number there. Usually that number is going to be a decimal number. That is this. That is the average atomic mass. And we'll talk more about that as we get more into the periodic table. Okay, but that atomic mass, usually a decimal, right? Sometimes it's up here. Usually it's at the bottom of the square like that though. Okay, so those are generally the 4 pieces of information you'll find in every single square on the periodic table. And those are important to know and memorize. Okay, not real hard to do. Well, thanks for tuning in, you guys. I hope you have a great day, and I will see you in class. Bye-bye.